Hey, welcome back, class. Let's take a look at the concept of dilutions in this video. I'm going to assume that for this lesson, you've already watched my other lesson video on molarity. If you haven't, you're going to want to stop right now, go watch that, make sure you understand the concept of molarity, because that's how we're going to open this up. We're just going to use it. I'm going to assume that you remember how to do that. And then we'll be able to jump in and look at the concept of dilution. So with that said, let's just go ahead and jump into this video. You'll need your eyewear. You'll need something like a triple beam balance or a digital scale and some water. I already have some stuff pre-set up just to kind of help streamline and speed the lesson up a little bit. But as always, there'll be chapters in the video description for you to jump back and forth to wherever you need to get to the main points that you might need to revisit and relearn. All right. So I've got a couple beakers here. I've got some graduated cylinders that has some water in it already, and I have some sodium chloride. It's cheap. It's inexpensive. Costs little to nothing. No need to use expensive, reagents and stuff like that, chemicals, for what we're doing. So you would have a triple beam balance. I'm going to use a digital scale just to help speed this up. Let's jump in and see what we've got here. All right. So I'll come over here. I'm going to take one of my beakers, and I'll come over here and I'll use the tare function to zero it out. And then I'm just going to start adding in. I'm going to add in some salt. All right. And I'm just sort of winging this. All right. I have an idea, based on what I'm about to see here on the scale. I have an idea of what the calculation will be, but I'm trying to mimic what you would be doing in lab. So in lab, you're going to be asked, you're going to have a recipe, or you're going to have to come up with the recipe and figure out, what does my concentration need to be? How much solvent do I need to add? How much solvent? How much do I need? How much solute do I need? This is the solute. Sorry, I may have said that backwards. The solute, remember, is the substance that's being dissolved. The solvent, that's the substance that's actually doing the dissolving, right? Right now I'm at 3.569, 3.569, 3.56, 3.57. So let's just go with 3.57 grams, all right? I don't know. Yeah, let's go with a little bit more. Let's go with one more. We'll go with one. I've got 4.397. So let's go with 4.397. So let's go with 4.40. Let's go with 4.40, all right? So, all right, so let's jump in. Let's get to our writing space. So I've got a beaker, right? And this beaker, right now, I have in here, ignoring the mass of the beaker, the mass of the solvent right now, the solute, we said was 4.40 grams, and this is sodium chloride. Okay, so I've got 4.40 grams of sodium chloride. I have right here 100 milliliters of water. So right now I have my volume equals 100.0 milliliters of H2O. So I'm going to add that in, right? Being very careful to not spill, splash, whatever, especially when I'm close to my iPad. All right. Now we're going to assume, I'm just going to take a glass stirring rod, mechanically move the molecules back and forth, cause them to interact a lot faster. That's just a fancy way of saying stir the water and salt together, right? Stirring, just to speed this up, right? And let's assume that that's all completely mixed and there's no solid solute left. There's no solid sodium chloride left here whatsoever, okay? And to be safe, I'm going to take this and put this off to the side just like I did. Just good lab practice. I want to mimic that for you. All right, so now I've added 100 milliliters to this. So we know we can use the molarity equation, and we know that moles of solute per liters of solution can let us know what the concentration of this is right now, right? Let us know the concentration of this. So moles of solute, well, we've got to figure that out. We've got grams of solute, but we don't have moles of solute. So remember, we just have to multiply by the molar mass, right? And so let me take this. I'll just bring this down over here, right? And so we multiply by the molar mass, then we know that that's 58.44 grams of sodium chloride for every 1 mole of sodium chloride. Like units cancel out. Make sure you do that. So we've got 4.40 divided by 58.44. That gives me 0.075290, a bunch of other numbers, right? Moles of sodium chloride. So 4.40, 3 sig figs, so we'll stick with 3 sig figs, 0.0753, right? Because remember, there's our first, there's our second, there's our third significant digit, and this 9, there's a strong argument that says that 29 would round up to 30. So there it is right there. And of course, this is moles of sodium chloride. So with the tools that we're using in class, those 3 sig figs, this is going to work out really, really well for our calculations. So now we know that we've got 0.0753 moles of sodium chloride divided by liters of solution. So remember that 100 milliliters is 0.100 liters of solution, right? 0.100 liters of solution. And then we remember that moles per liter, that all of that is molar. And then the sodium chloride, just bring that down because it didn't cancel out. It's kind of just like a variable in math class. So now we just have to divide those two numbers there and reduce that to some number. So we've got 753 divided by 0.1. You should see that it just took your decimal and shifted it one place because we essentially reduced it by 1/10, right? So 0.753 molar. So that's our concentration. So this is a 0.753 molar sodium chloride solution. This is what we know, all right? That's what we've made right here. No dilution has occurred yet. We just made a solution. Now, we're going to call this our stock solution. All right, this is our stock solution. So if you have stock, that means it's where everything is kept, right? So I stockpile this. I put this here. It's all kind of right there. So a stock solution is this is the stuff you're starting with. All of your stock is here, and you can take it and you can move it elsewhere. So that's what we've done. And so oftentimes in lab, what you do is you make stock solutions, and then you just use a certain amount of that solution, and you just then it just makes it easier for you, so you don't have to keep remaking it over and over and over again. You already have it there, right? So let's do this. Let's move this over here. We know that that's our stock solution right there, and we also know that we have right now 100 milliliters of that stock solution. That's what we're starting with. So now let's just say that I take some of this stock solution and I pour it into another beaker. So I'm just going to pour half because we want to just work with some easy numbers. Now, again, we would use a graduated cylinder to make sure that we've correctly measured out half. Because remember, beakers you don't use as a measuring device. There's a lot of error in those lines. Those are estimated numbers. But for the purpose of this video, let's assume that by pouring it here to the 50 mark line, I've got 1/2 the amount. Both of these solutions have the exact same concentration. It's just 50 milliliters of 0.753 molar, 50 milliliters of 0.753 molar. It's the same thing. If this were Kool-Aid, this cup of Kool-Aid and this cup of Kool-Aid, they would taste the same, they would look the same, et cetera, et cetera, et cetera. They have the same amount of sugar crystals and Kool-Aid crystals and all that other good stuff, right? So here's what I started with from my stock solution. I don't need my stock anymore. I'm gonna go ahead and just put that off to the side. So now what I've got is, I'm gonna draw this beaker just a little bit bigger for you. So now what I have, is this right here, right? And my stock solution just off to the side. Okay, so there's a certain molarity to this and a certain amount of volume to this. Well, we know the molarity, 0.0753, or 0.753 molar. That's the molarity of it. And we know the volume of this. I've just poured 50 milliliters in here, so there's 50.0 milliliters. Always want a decimal, so it's a measured value. Okay? So now I could call this solution number 1. This is the first solution that I'm going to start with. That was my stock, and I just poured out what I need. I just poured 50 milliliters. I could have poured 5 milliliters, 7.5, 13 milliliters, 11, 23, it doesn't matter. Just this is what I'm starting with, right? Now I'm going to come over here, and I'm going to pour in 25 milliliters of water into this, right? I'll come over here, and I will grab my glass stirring rod. I'll come over here, I'll do some stirring. Just so it's evenly mixed, right? And so now if you think about it, I had my original solution, what we see here, solution 1, but now we technically have solution 2. It is the diluted solution. This right here is our diluted solution, right? So if you think about it, this solution, it has a molarity and there's a certain volume there. Well, let's think about it. If we start off with 50, this one would be 50 plus the 25, right? And I guess I need to not be a hypocrite. So 50 milliliters plus 25 milliliters equals 75 milliliters, right? 75 milliliters. When I say hypocrite, just I tell my students all the time, never write a number without a unit. So I want to make sure that I'm exercising properly here. So the question is, what's the new concentration here? Well, here's where our basic algebra comes into place. We have two things that we can set equal to each other. Well, solution 1 has a molarity and it has a volume, so I can say M1V1. This second, I'm just going to say M2V2. And in chemistry, there's a wonderful relationship. M1V1 equals M2V2. And like your math teachers have taught you, so long as you have every variable but one, you can solve for that one variable. And if you have more than one variable missing, well, then you just figure out how to isolate and get one variable. And your math teachers have taught you things like that, right? And we'll have times like that. And if you have more than one variable missing, you would figure out how can I eliminate a variable? How can I substitute in for another variable to then find this one, right? So they teach you those things, all right? Here we just need to just realize that, hey, we have M1, we have V1, and we have V2. Question is what's M2? Well, do what our math teachers taught us, and let's isolate the variable. Well, we would want to divide this side by V2, and that cancels out. So we'd want to divide this side by V2. That cancels out. So now, since that's all canceled out, we see that the new form of the equation that we need is that. If we just plug and chug into that, we've got our answer. So, M2 equals M1 V1 divided by V2. The molarity of the first one is 0.753 molar times what we had, which was 50 milliliters, so that's 0.050, right? Liters, divided by the V2, the volume of the second one, which is the 50 plus 25, so that's 75, which would be 0.0750 liters. We can see immediately that liters, that unit cancels out. It's wonderful. The math works when we use it correctly. So we have 0.753 times 0.05. You should see that that gives you half that value, right? And then divided by 0.075, and then that literally gives us 0.5. That's what's in the calculator. I had no idea that this was the number that was going to come up. As a matter of fact, when I first was doing this, I had a different solute amount in mind and kind of knew what was going to happen. And then I just changed it up when I did this video. I had no idea that the amount of salt that I was going to use was going to end up giving us this number here. But this is great because this is what's going to happen in lab. You're going to get a number like this and you ask yourself, well, how do I report this? Well, we reported M1 with 3 significant digits, 0.753. Well, here's 0.5, that's 1 sig fig. So, and of course, you know, this unit molar, it comes down. So the final answer for this would be 0.500 molar. That would be the concentration. That would be M2. And that makes sense that we get a number that is lower than what we started with. Because we started off with our stock solution with 0.753. We've added water. That means we've diluted it down. So if you get a number that is not lower when you know you've diluted it, you know you've done something wrong with your math. You know that somewhere along the way you used a number incorrectly or entered it incorrectly into your calculator, you punched it in wrong, so, something. You've done something wrong from somewhere. Always backtrack and ask yourself, where did I start? What's my stock solution? How much am I starting with? There was 100 milliliters of the stock solution. One of the most common mistakes I see is that when people do something like this is right here you see we started off with 50 milliliters, but what I'll see students do is they'll put 100 milliliters there because they'll say, well, that's what I have. I made 100 milliliters, but we didn't use 100 milliliters. 50 milliliters of what we made is stock is still over here. We only used 50 milliliters of that. So that was our original, was 50 milliliters. Now, if I had just used that and then added 25 in, then yes, our first volume would have been 100 milliliters. So it's all about listing out your variables. You'll see how I drew a picture and listed out my variables. By doing that, it really helps to make sure that you don't confuse your numbers and put something in the wrong place. And if even one variable is out of place, then you'll get an incorrect answer. And then that's why it's another reason why it's so important to make sure you have your units when you're showing off your work. Because the units here, the liters units, notice they cancel out and you're left only with the molar unit, which lets you know that you're probably doing something correctly because the only unit remaining is the one that you're actually solving for. That's a check and a balance for your work. All right. So hopefully that helped. And now we could do this again. We could take more water, put it in there. I could put 15 milliliters, and then this would be solution 1. This would be my M1 V1. And then I would figure out the new volume. That'd be my volume 2. And then we could figure out what the molarity is by using this molarity volume relationship equation. M1 V1 equals M2 V2. All right. So I hope this helped. Do some practice problems and then get with me if you have any questions, and be ready for class, be ready for lab. You'll be doing stuff like this throughout the semester. A lot of times I'll have you make your own solutions. And so your job is to know that, okay, I'm going to need this much here. I need to make this solution. This is going to be something ongoing. I probably should make a stock solution. So let me make a stock solution, and then I'll just grab what I need from that stock solution and then dilute it down to whatever I need. So I'm wasting less material. That's the whole purpose of a stock solution. So you have something to draw from, and then you just use it as you need it. You just change your recipe up. Glad you're here. It's always great learning with you. Go do some practice problems. I'm gonna clear out. I'm gonna clear out. Go get some coffee, and then go move on to the next lesson. You take care. Have a good weekend, and I will see you soon.